Okay, let's do this, guys. We have a circuit here. I'm going to put 24 volts to the battery. I'm going to put a 12 ohm and an 18 ohm here. Let's go with 90, 90, 90 ohms, ohms, ohms. Okay, people, what you do here is you need to immediately draw the simplified diagram. Okay, so our simplified diagram gets rid of anything that is in pure parallel with each other. So I'm going to circle the things that are in pure parallel right now. Here, here. Okay, so when we draw this now, we're going to go down here. We're going to draw 24 volts. So we're going to just copy. Okay, you should be good at copying things down. So I've copied the 6 down. I'm going to copy the circled 2 things down, but I'm not going to put a number for them yet because I don't know what it is. Down, here's the tone. This is. Why don't we calculate it right here? 1 over RT. Now when I say RT here, I'm talking about RT for the circled stuff, not the total of the whole circuit. Okay? So that's going to be 1 over 12 plus 1 over 18. Now, do not round when you do this. 1 divided by 12 plus 1 divided by 18. Now, I think I messed that up. Did anyone work that out on a proper calculator? So overall was 7.2 when you flip it and everything. So we get RT is 7.2 ohms. Now that seems right based on what I've told you about this. The total for 2 things in parallel should be less than the lowest. 7 is less than the lowest, so I'm cool with that answer. And even if we got that wrong, it's the process here. If you just screwed that up and it was supposed to be 9 or something, oh well, big deal. Okay? Now for the purposes of this, I'm just going to double check.
17.4.
What's that? It should be less than the lowest though. So I'm cool with the 7.2 at this point. It is 7.2. Okay. So now I go down here. I put in. Now, this one here, guys, there's 3 90s in parallel. Now, if you don't want to think about it, just use the formula. 1 over 90 plus 1 over 90 plus 1 over 90. And yes, you should get 30 when you do this. RT equals 30. The shortcut there is there's 3 the same, you divide by 3. 2 the same, you divide by 2. Okay? So there's a 30 ohm. Okay, now, from this circuit, we find our total. So our total will be the same for both. This one's going to be 32, 38, 45.2. There's our total. We have the total voltage. Now we find the total current. IT is equal to 24 over 45.2. You get 0.53 or 0.531 if you round it. That's what's current measured in. Good. Now, this is getting a little bit messy, right? But I think we have room if we don't show all our work. So what our next, well, even if I did show the work, let's show at least this one. V is equal to IR. So that's 0.531 times 6 is Let's go with 3.2 volts. So I'm going to put 3.2 volts like this. Guys, I need you to look at this and take it in. How did I get the 3.2? I did I times R. Why did I put it up like that? Is that the proper way to measure voltage, Jared? Yeah? Yeah, because I put it in parallel, right? So that's how we communicate a voltage. We put the voltmeter in parallel and we write it down. Okay, now, go around the whole circuit and tell me all the voltages. So you got to do 7.2 times 5.31, or 0.531. Okay, so 3.8 volts. This will be 1.062, so 1.06 volts. This one we get 15.93. Okay, now what? Now we're going to need to make a chart to organize ourselves here, guys. So what I'll do here, okay, V is equal to IR. So I like to give the charts like this. What's wrong? I'm going to post this so everything will be kind of more or less there. Okay, guys, can we go around in order? Tell me all the resistances. 6, 12, 18, 2, 90, 90, 90. Okay, the 90s are all going to have the same answer. So if this were a test situation, you'd only get really one. Okay. Now, what were the two things that we didn't have to calculate in our so-called simplified diagram?
The series rate.
Well, the 6 was already a 6, and the 2 was just a 2. So give me the voltages for the 6 and the 2. The 6 was 3.2. The 2 was 1.06. All right. What else do we know here? Well, hold on. The 6 and the 2, if you follow the current coming out of here, which we calculated somewhere, 0.531. Would the, guys, follow the pen here. 0.531 comes out of the battery. Yes or no? Does it go through the 6? Yes. Oh, so I guess we know the current on the 6 anyway is 0.531. Okay, we know the current to this one is also the same. Now, the voltages, the first thing we circled, the 12 and the 18. What was the voltage drop across this one? Oh, 3.8. So the 12 and the 18 both had a voltage drop of 3.8. What was the voltage drop across the 390s? 15.93. Okay. Now what? I is equal to V over R, 3.8 over 12, 3.8 over 18, 15.93 over 90, and copy the answer twice. That's it, guys. I'm going to stop the video now. You guys can go ahead and fill that in.